Hello, welcome to this video on the concave lens. In previous videos we've discussed another type of lens known as the convex lens. And you might remember that the convex lens looked like this. And you might remember that we talked about what the convex lens does to light rays that arrive at the lens. So hopefully you remember that the convex lens bends light rays like this, for example. And you hopefully also can recall that the convex lens gives rise to images. So if I have an arrow over on this side here, that arrow may give rise to an image on the other side of the lens, like that. So we'll be talking about all of these ideas and concepts in this video, but for the concave lens. And you can see that the concave lens is shaped differently to the convex lens, but there's lots of things that they have in common. So let's first discuss some of the common terminology or words that convex and concave lens have. So you see here this point, the center of the lens, that's O, that is known as the optical center, just as for the convex lens. And you see these 2 points here, F1 and F2. These are just like what we had for the convex lens again. These are known as the principal foci. What I will do is I will move these down here. Okay, so let's put this stuff down here. And what else do we have in common? We also have, yes, I forgot to mention that this line here, this straight line here, which runs through the middle of the, which runs through the optical center, this is known as the principal axis. Again, we introduced this when we discussed the convex lens. And finally, just as for the convex lens, the distance between the foci F1 or F2 to the optical center, that's what's known as the focal length. Okay, so this distance is F, the focal length. And this is F as well, little f. So let's discuss what a concave lens, how it affects light. So let me change color to say this. Now, when a light ray comes in parallel to the principal axis like this and reaches the concave lens, the lens again it affects the light ray. It bends the light ray like this. Okay, the technical word for this is the light ray refracts. Okay, so we say that let's write that the light ray it bends, but the more technical word is that it refracts. Okay, so refraction is the word that describes the bending of light waves or light when it travels from one medium, so from one region such as air into another region such as glass, okay, which is what the lens might be made out of. All right, and so let's draw another incoming ray. In fact, let me draw it a bit higher up here. Now, the interesting thing here is that these rays, these light rays here, if we were to extend them back, what we find is that they appear to be coming from this point here, this focal point F1. So let me do that for this one here. So in other words, whenever you have light rays that arrive in like this parallel, okay, so that we would say this light ray here is parallel to the principal axis. Whenever you have light rays that arrive in that are parallel to the principal axis, to somebody it would appear to somebody over here as though the light rays are coming from this point here, this focal point here. Okay, so to show that, we draw these lines back, and they should meet here. So let me just draw one more, just so you get the idea. So what I'm saying is that if I were to draw another ray coming in like this, okay, it would bend something like this here, okay, and it appears as though it's coming from here. Okay, so hopefully that's clear. Let me just get rid of that here. So let's discuss now what happens to a light ray that is directed towards the center of the lens, the optical center. And actually this is really straightforward, because such a light ray just passes straight through. So such a light ray, as you can see, does not bend, okay, or does not refract. Okay, so this is true whenever you have light rays that are directed towards the optical center of the lens. So let's put these things together now and see how images are formed by a concave lens. So our object here is going to be a simple arrow. So this is our object, just this arrow here. Okay, so that's our object. And let's use the concepts we've discussed in the video so far to see how the concave lens forms an image of this object. So what we do is we pick a point on the object, and it's simplest to pick, say, the top of the arrow here, and we draw some light rays. Let's draw a light ray from the top that is parallel to the principal axis. Okay, so we know that such light rays will be bent by the lens like this. And let's also draw one from the top again that goes through the optical center. And you know that such rays just go straight through like this without bending. Now the question is, what would somebody over here see? So what we mean by that is, imagine a person or somebody's trying to view what's going on over here. So what I'm drawing here is somebody's eye. Okay, so hopefully you get that. This is somebody's eye. And these light rays, okay, they're entering the person's eye, right? So what does the person see? Well, what the person sees is this. As we discussed here, this light ray here, to the person it appears to be coming from the principal focus, f1. And notice here, at this point here, this ray and the bottom ray here, they meet. Well, they seem to meet here. Okay, so for the person over here, it looks as though these rays are coming from this point here. And this is exactly where the image of this object forms. So in other words, the image of the arrow forms here. Let me draw that again, like this. So notice we started by drawing the rays from the light rays from the top of the object. We drew them, and what we find is that the top of the arrow to the person appears to be here. Okay, so this here is the image of the arrow. And notice that the image, there's a number of things to note about it. First of all, this image, you can see it's smaller than the object arrow. Okay, so we say that the image is diminished because it's smaller, and that's always going to be the case with a concave lens. Okay, so the image is diminished. Notice it's the right way. It's pointing in the same direction as the object arrow here. So it is upright. And thirdly, note also that this image here is a virtual image. A virtual image. You might remember when we were talking about the convex lens that with the convex lens you can get virtual images as well. And what that means is we can't form this image. So we can't form this image on a screen. This is in contrast to, you may recall from the convex lens, this is in contrast to a real image. Okay, so for a real image, you can form the image on a screen. Okay, thank you for listening.